Assalamualaikum warahmatullahi wabarakatuh. Okay, welcome to Solid Mechanics and Structures Lab. Okay, today we're gonna conduct the experiment entitled Torsion Test for SEMM2921. Okay, for the first step, measure the diameter of the specimen, this one, specimen, using a micrometer. Okay, this one is not micrometer, this one is vernier caliper. Okay, take average of 3 reading. Okay, diameter. Then after that, you take the measurement of the parallel length. This one is parallel length, the mark here. Okay, parallel length and overall length. Overall length from here to here, total, like this. Okay. Next step, draw a line along the shaft using a marker pen. Okay, like this. You see the marker line, the marker. Alright. This will allow you to observe the twist of the specimen as the torsional load is applied. Okay. Next step is we clamp the specimen into the chuck. Okay, this one is the chuck specimen. Okay, we will clamp like this. We clamp the chuck. Okay, for the next step, after we put the specimen into the chuck, okay, we need to put the torsiometer. Okay, torsiometer. But before we put the torsiometer on the sample, we need to do balancing first. Okay, see the water level here. Okay, we need to make it center. Not only center, the top also 0. Center and 0. Okay, like this. Okay, see this one, the water level is center, this one is 0. Okay, right. Okay, after we do the balancing, then only we can put the torsiometer here, like this. Okay. Alright. Okay, next we go to the table. Okay, see your lab sheet for table 1, specimen data. Okay, measurement number, diameter of shaft and gauge length. Okay, this one, the diameter of shaft you get from the first step. Okay, the first step you need to take the reading of the diameter, right? Okay, so this one you can write it down, then take the average. Okay, for table 2, result of torsion test. Okay, so you can see at A when the material is still elastic. Okay, first table, top. Okay, top you need to take the reading from here. Okay, this one, top, Newton in Newton meter. See, Newton meter. Okay, next is angle of twist in radian from torsion meter. Okay, angle of twist is from here. Okay, this one, torsion meter. Before we start the experiment, make sure the reading is 0. Okay, we can set from 0. Okay, next is angle of twist also, but in degree. The previous one in radian, right? But this one in degree. From angle of twist meter. Okay, the angle of twist meter is this. This one. We got 2 here. But for the first table A, we use this one. For the second table, that is B, we use this one. Okay, but for the table A, we need to set the first one to 0 first. Okay, this one is 0. See, 0. Okay, now we have set all the reading to 0. Then we can begin the experiment. Okay, first, okay, look at here. What is 0, 0, 0, right? Okay, the first one is 0. Okay, next is 1 degree, angle of twist. Okay, look at here. I will twist this wheel here until 1 degree. Okay, 0.5, 1. Okay, after 1 degree, okay, you need to take down the reading of torsiometer and torque. Okay, and put it here. Okay, torsiometer and torque. Okay, after you write down the value of torque and torsiometer for 1 degree, we proceed to 2 degree. Okay, see here. Okay, I twist again from 1 degree, 1.5, 2. Okay, the reading here is changing. Okay, take down the reading again. Okay, next we repeat the experiment. For the angle of twist is for 3, 4, 5, 6. Okay, until yield. Okay, until yield, you see, how do you know the specimen is yield? Okay, let's say at, okay, this is not 6, maybe 7, 8, 9, 10. Okay, okay, let's say at at 15 degree. Okay, at 15 degree, the value of torsiometer is 0.2, maybe lah. This one I just write. Okay, then you next, you change to 16 degree. The value is same. 17 degree. The value is same for the torsiometer. This one. Okay, the torsiometer. The reading is same. Okay, that means your specimen has yield. Okay, when the material has yield, we move to table B. This one. Okay, for table B, you need to take the reading from here. The angle of twist. Okay, first you need to set to 0. Okay, set to 0. Okay. What is the difference between this one and this one? Okay, this one the scale is small, but this one the scale is big. The increment is big. For the first one, we just increase 1 degree, right? 1, 2, 3. But for the next step, for the next scale, the increment is 20, 20. 20, 40, 60, 80, 100. Next, we will rotate the wheel here, okay, from 0 to 20. Alright. 10 degree. Alright, 20 degree. Then we can take the reading of torque. Okay, then we repeat the experiment until from 20 to 40 like this. 30, 40. Okay, 40 next. Okay. Then you balance back the water level. Okay, center. Then you take the reading again. Right. So after for 20 the value of torque is 15, right? Okay, for 40 just now 60, right? Okay, you continue. The increment is 20. Okay, you continue until not until 100, until fracture. Maybe 200, 300, 400, depends on the material. Okay, after we finish the experiment, the sample will fracture like this. Okay, for the previous step, we draw the straight line, right? Straight line. After the experiment, you can see the line here. See, it become twisting. See, alright. So this is the final product.